All right, so here's a second video dealing with the Koch curve. I had that introduction and kind of how to explore it. So in this video, I want to actually fill in this table and see how does this actually give us an exponential relationship. So last time, I'm just going to pop this over here. We're going to do a little bit of drawing over here. We started with a stage 0 that was 27 in length. So stage 0. And we noted that if we wanted to get to stage 1, we needed to cut this in thirds. So we're going to divide by 3. And then we're going to add 2 of these right here, which means that we're actually getting 1, 2, 3, 4 new segments. So we're really multiplying by 4. And so our stage 1 looks more like this, where if we think back, each of these is 9 in length because we divided 27 by 3. So I've got 9 plus 9 plus 9 plus 9. Or a way to think about this is I started with 27, I divided by 3, and I multiplied by 4. So I'm just going to say 27 times 4 over 3, and we're gonna see where that comes in. And that gives us the 36 that we see right here. So, and then to get to the next, to stage 2, we're taking our stage 1. We are dividing each segment into thirds. So I'm going to go thirds. So for this, I'm taking 9 and dividing by each of these segments was 9. I'm dividing each segment by 3, and then I'm making it have a multiple of 4, so I'm multiplying by 4. So there's a quick way to do this, and we're going to look at that in a second, but just for the sake of making sure we go through this, I've got 3, 3, 3, and 3 for each of these segments, because if I took 9 divided by 3, now I've got 4 of those fraction pieces, so I really can label all of this. And this is what we see in stage 2 in the image that I gave you. Got all these 3s. My brain wants to make this easy on myself, so since I've got 4 segments that look the same, 1, 2, 3, 4, I know that I've got 4 3s in each of those segments, so I'm going to go 4 by 4 by 3, which gives us 48. All right, so we're seeing 48 right here. And if I take 48 divided by 36, 48 divided by 36, that's going to give me the same ratio, 4 over 3. I can for the ratio, 4 over 3, or excuse me, 48 over 36. Simplify those by dividing by 12, and I get 4 over 3. So those are equivalent fractions. All right. So if I want to keep going, I'm starting to see that, okay, my constant multiplier, this thing that I'm going to multiply by 4 or multiply by 4, divide by 3, or divide by 3 and multiply by 4. We can do those in either order. You might practice going from stage 2 to stage 3. If I were a better artist. All right, so this is our stage 2, and we're going to do the same thing. We're going to take our thirds, and we're going to make thirds of those. So we've got, these are each segments of 3, but we're going to start cutting them. So they're going to each become thirds of 3, which gives us their lengths of 1. And doesn't have to be anything beautiful, just to get the visual, but all of these have a length of 1, and we're multiplying by 4. So for this case, we started out with a length of 48. I'm dividing that by 3, and then I'm multiplying it by 4 to get my total length. So if you're using a calculator or some other device, that's perfectly fine. I already have one loaded. So 48 times 4/3. We're looking at 64. So this is our pattern. We're multiplying by 4/3 every time to fill in our table. 4. I might actually just continue to do that. So let's times by 4/3. I get 85.3 repeating, so 85 and a third. 85.3 repeating. Put in a few there. We get the idea. We already know that all of these are going to be constant multipliers of 4. We see that pattern happening visually when we do the Koch curve. So we can just, all of these ratios are going to, this is our constant multiplier. It's what we're multiplying every time, is we're multiplying by 4 and dividing by 3. So I can just carry that pattern all the way through. 113.7 repeating. Let's keep going. And then 151.70, we'll round it. I'm going to leave 7 and 8 for you to do those multiplications. So let's jump onto some of these next steps just to kind of work through that. See how many of the stages you can draw. That was more of a see what you can draw. I made it to stage 3. If I was really ambitious, maybe I use a bigger piece of paper and I try and do the next step where these are then lengths of a third. But you'll notice just drawing on this is a little bit small. So after we get through stage 0, 1, 2, getting to stage 3 is really the hope is that we have the pattern down. So if you did pictures, great, put them here. And then we've got our lengths that we're recording in the table. Constant multiplier, we found out that we multiply everything by 4/3. So that's all we're putting right here. We're multiplying by 4 and dividing by 3 all in one. So use your constant multiplier to predict the total lengths of stage 4 and 5. We just did that together. We made those predictions because I was not going to be able to draw those. So those are those predictions. How many times do you multiply the original length at stage 0? Okay, this is a really interesting idea because if you notice, when we have the stage, so this is looking at step 6. So if I've got stage 0, so stage and length, that's really the relationship we're looking at. So if I have stage 0, we're starting at 27, right? We just found out that we have a constant multiplier where we're multiplying 27 by 4/3 to get stage 1, which was 36. So I'm actually going to write this as just as 27 times 4/3. Okay, so I know that this in yellow right here is the same value as 36, but I'm just writing it like that. Okay, so then I'm going to do the same thing. I'm going to multiply by 4/3 again to get to step 2. And what we see that is I'm going to have 27 and 4/3, which is our 36 value, and I'm multiplying it by 4/3. Well, this creates an interesting experience because now I have repeated multiplication, which means I can rewrite that as an exponent. So this can be written as, also known as, 27 times 4/3 to the second power. Well, that's interesting. let's take a look at step 3. So I'm multiplying by 4/3 again to get to stage 3. And so I've got 27 times 4/3 times 4/3 times 4/3. Oh, that's interesting. So I've now got 1, 2, 3 of the same multiplication happening. So this is also able to be written as 27 times 4/3 to the third power. Now, this is interesting because we have a relationship here. We see that nothing changes except our stage number becomes our exponent value right there. So we all of a sudden have a shortcut to getting the total length by just using the stage number. So when we see something like step 7 or step 8, we can rewrite those exponents. So if I wanted to go, let's say I wanted to skip all the way down to 4, 5, 6. I wanted to go to stage 6. I know that I can rewrite that as 27 times 4/3 to the 6th power, and then I can evaluate that. So we've got our expression. Are the values the same? You can go through that. Interesting here is step 10 asks us to do a graph. So when we're doing a graph, recall back to last week. You can create a table where we have stage number. We'll go S sub 1 and length, total length, L sub 1. So if I have this stage 0, I have 27, right? This is why this graphing program is great, is because I could write 1 and then I could just write 27 times 4/3. I don't need to actually evaluate. Like, we know that it's 36. We've calculated that, so I could write that as 36 also. But I don't need to. I can keep it like this because we're going to see a pattern. All right, I'm going to change my view for a moment. 0 to 10, and y-axis will go 0 to 200 right now. And then now we can move around a little bit. And we've got our first value, 0.27, 136 right there, evaluated for us. Now what's great here is I can, let's just go down all of our steps. We'll go to 10. I can copy this, copy, paste, and I know that I need to multiply 4/3 twice, right? 4/3. And once again, it does the calculation for me, gives me 48. Now, the other thing that you could do is I could do the shortcut that we just found, which is 4/3 to the third power, and then paste 4/3 to the fourth power for stage 4, 4/3 to the fifth power, 4/3 to the sixth power. And hey, this looks a little bit different than what we've done with our linear relationships. This is a pretty classic exponential relationship, what we have going on here. If I zoom out a little bit, you'll see this exponential curve. It's going to keep with that pattern. So an exponential curve has the form y equals a times b to the x power, where x is your independent variable, y is your dependent variable, and then a and b are these constant values. So for us, we had 27 as our a value, and I'm hoping you remember that we had 4/3. And check that out. So there's a little bit of reading in that workshop doc, and then there's a few more tasks in episode 2. I just wanted to show you a little bit more. Where's the other? Oh, here we go. A little bit more about this investigation. So you'll notice right here, it gives you that function. And then also it shows you the difference between expanded form of an exponent and exponential form of an exponential function. So I hope you found this helpful, and reach out if you have questions. Thank you.